Hello, welcome to the second video for pre-calculus here for the video lesson. So this is for advanced factoring. Now, I do have the answer key of all of it here, but I do want you to just get this part here in the box so you can see what their names are. Just these are the 5 common ones, and those letters that you see there are part of the examples that I have at the bottom here. But just go ahead and get that. And then you can pause this if you want to get that too, but I actually want you to get this as I go along with it. You don't just write it all, but go along with it just one by one. So let's go ahead and get started with you know, you can read this to yourself. I think you can go over that, but let's just get started with the examples. So the 6 solid examples. Let's get started with A. Now for A, this is like just in general knowledge of putting things together that you've seen before and that we've done somewhat, but then this is the next level. So difference of squares, it won't pop out at you right away. Usually you see a to the power of a squared minus b squared, that's for sure. But then you have a to the power of 4 minus b to the power of 4. Just understand that you can kind of manipulate the squaring to look like that, and it actually, you can apply the difference of squares to A. So that's why A goes with A for difference of squares, is that's exactly what we use to factor this to this, and then eventually this guy, you see another difference of squares here, so it becomes these two. So that's the final answer, because this doesn't have a special one, even though it kind of looks like it does, but this doesn't have anything of these 5. So this stays the same. This guy here became these two because you saw another difference of squares right here. So that's the final answer, fully factored from the original a to the 4th minus b to the 4th. That's A. For B here, you have a structure. Now, it takes a while to get used to these, but for sure you know 3, like a trinomial, and then it takes a while to see this as this structure here. So you can go and factor into this. So you know it's a perfect trinomial where you have to kind of see it. You got to kind of see that, oh, okay, I have a squares here. I can do this, I can change that to this, and I can change that to that. You kind of do the sides first. And in the middle here, kind of could follow this now. 2ab. So if a is 2x, 2x. If b is 5y, 5y. And that's my 2 from that 2. So I put it like this. And if that follows that, this is the same. And it is, because if you do this, you get this guy here. So, perfect. We can then factor to this form. If you have something like this, you can go to this factoring, and that's exactly how we finish it off. A plus b, and then squared, in parentheses, and then squared. So these take some time, but then hopefully you can kind of see squares, and then this 2ab in the middle, and then it just takes some time to get used to, but it's pretty straightforward at the end here. So let's go to C. Now this is, you know, I think we all know our squares, perfect squares, but sometimes you gotta get used to knowing some of these simple perfect cubes. 27 is one of them. 3 to the power of 3 would be 27, so you can rewrite this like this. And now you can use the difference of cube formula. So for C, I put it here, C. So if you see something like this, this is what you can use as a nice special form of factoring. And that's exactly what we do here. So my a is m, and my b is 3. So a minus b. And then a squared plus, and then this is actually a little bit simpler, a and b. Over here we're kind of dealing with a 2. But here, there's no 2. Just a and b together. So 3 and m, and then plus b squared, 3 squared, 9. Nice factoring. From this to this, and then nice. And then this is now the other one, right? There's 2 of them. Difference of cubes and the sums of cubes. There's actually 1 for each. For the difference of squares, is just kind of 1 for this one. There's not really a sums of squares for special factoring. So, but there is for cubes. Now again, this will take some time for you to know some perfect cubes. Again, 8 is for 2, perfect square cube for 2, and then 125 would be for 5. Okay, sometimes that gets you got to get used to it. So you got to know some cubes eventually, but you can take the cube root of that, you'll get 5. Take the cube root of that, you get 2. So, you know, you kind of know this is to the power of 3 to the power of 3. So, oh, okay, it must have to do with cube somehow. So this goes to that. And now this guy here, I'm sorry, this is a 3. It shouldn't be a 2. Right here, this is a 3. Yeah. So that goes to the sums of cubes right there. That's why D is part of that. And now if you see this kind of sums of cubes has a same, opposite, always positive, same, opposite, always positive. Kind of like the little rule here. So same, and then always positive here. Okay? Oh, that's it right here. Same. Ooh, that means this is opposite. Okay, same, that means this is opposite. So that's another little tiny error there. That is then minus. So it's same, opposite, always positive. There you go. That's correct. So if you do double distribute this, you would get eventually this back. Alright, so a few more. Now, this is where you have to be careful with the GCF, sorry. So greatest common factor. You do that first, because right now you don't see really something going on here. Like, this is just, it can't fit into none of these 5. So okay. But I do notice that they all share 3, factorable by 3, and they all have y's. So that's exactly what we factor out. And then, what happens is that this has become now one of these perfect trinomials. It has this form, if you kind of break it down like this. The a squared, 2a plus 2ab, and then b squared. Very nice. So then it goes factors to that special factoring like that. Perfect. Okay, this is, instead of making a video all over again, sorry for the last part here. I think I wanted to end the video quick. I thought it was a bit too long, but I think sometimes I just didn't catch this one, so sorry about that. Of course, here, this now has the sum of cubes. So this is 64. That's one of them that has a 4, right? And then the 27 we've seen already with the 3. So no, you could factor this all the way. So you see your kind of A and B for your sums of cube, which is right here, right? And then that will then be like this. Well, perfect. This plus opposite always positive. You just follow all that from go to here. This and that matches up. Nice. This is a little bit a long factoring, but that's exactly what happens, and that's it. Sorry, this is a little addendum, little addition to the last video to end that nicely right there. Okay, thank you.